So topic 24 is solving exponential equations. The steps for solving an exponential equation is to make sure all the base values are the same and then set the exponents equal to each other and solve. So some properties of exponential functions or exponents in general. Let's say we have a to the x power plus a to the y power. These a's are called bases. Okay. So the number attached to the exponent. If we have two bases that are the same, then we can add our exponents. So since both of these have a base of a, we could say that this is the same as saying a to the power of x plus y. We took the individual exponents and then added them together to create one exponential. Okay. So that's one rule. Another rule is if we have a base, so like say a to the x, that is equal to the same base, let's say a to the y, then we can assume that x equals y as well. So if we have the same bases with different exponents equal to each other, we can say that their exponents are equal to each other. Okay. And the reason we do this is because a lot of times in these exponential equations, the exponents are going to be expressions. It's not just going to be a number. It's going to be, like for example, on number 1, that exponent is 2x plus 3. Okay. So when we set them equal to each other, if we're able to do that, then we're going to be able to solve for that variable. So let's go ahead and look at number 1. Remember on number 1, we have to have the bases be the same. So in this case, we have a base of 4 and we have a base of 1. So those are different, so we're going to have to make them both the same base. So if we look at 1, we can say 1 is the same as 4 to what exponent? 0. Because remember, anything to the 0 power is 1. So instead of writing 1, I can write 4 to the 0 power. So I'm going to rewrite the equation. Okay. Now that I have the same bases, looking back up here, remember, if I have the same bases equal to each other, I can do what to the exponents? Set them equal to each other. So now I have 2x plus 3 equals 0. And this is just a linear equation now that I'm going to solve for x. So I'm going to subtract 3, and I get 2x is equal to negative 3. Divide by 2, I get x is equal to negative 3/2, and that's our answer. So the only difficult part here is making sure we get the bases the same. Yes?
So if it was 1 for any equation, if it was equal to 1, it would end up being the exponent of 0?
Correct. Correct. Because anything raised to the 0 power is 1. Okay. Good. So now looking at number 2, do we have the same bases? Yes or no? Yes, we both have the same base of 5. So that means we don't need to do anything to change the base. We can go ahead and do what with our exponents? Set them equal to each other. So 3 minus 2x equals negative x. I took the exponents for each of them and wrote my equation. And then here, it's a linear equation. I'm just solving for my one variable x. So I'm going to go ahead and add 2x over. So I get 3 is equal to x, and that is my answer. So for these ones, we are just solving for our variable in the exponents. In order to get the variable out of the exponents, we have to have the same base. Yes.
Could you have added an x at the end, moved it over, and solved for 0?
Yes. Yes. You could have moved your x's to the left and your numbers to the right, and you would still get x equals 3. Okay. Now number 3. Okay, on number 3, do we have similar bases? No, because we have a base of 3 and we have a base of 243. So remember how we figure this out is we need to find a number. So 243 is equal to 3 to what power? Okay, and this is something you could just check on your calculator. So you know 3 to the first power is 3. 3 squared is 9. 3 to the third power, 27. So you know it's going to be higher than 3. You would check 4, check 5, so on and so forth. For this one, the exponent is 5. So 243 is equal to 3 to the fifth power. So I would rewrite this as 3 to the 1 minus 2x is equal to 3 to the fifth power. Because I need to have my bases be the same before I can bring down and solve for my exponents. Okay. So then I'm left with 1 minus 2x equals 5. I want to solve for x, so I'm going to subtract 1, and I get negative 2x is equal to 4. Divide by negative 2, x is equal to negative 2. So you typically want your bases to follow the smallest number. Besides if the number is 1, because if it's 1, then we know it's going to be whatever that original base is to the 0 power. But in this case, between 3 and 243, we typically want to turn, we usually want to keep the base that has the equation on it in the exponents, and then we change this to whatever that base number is. And for these problems in this course, that's going to work every time. There's not going to be a time where you can't find the exponent for those numbers. Okay. Let's look at number 4. So on number 4, do we have the same base?
Yes.
Yes, so that means we're going to do what with the exponents?
Just equal to each other?
Equal to each other. So 2a is equal to negative a. Okay. If I add the a to the other side, I get 3a is equal to 0. Divide by 3, a is equal to 0. Go ahead and try number 5. You're going to have to get the same base. So for this one, you should say that 1 is the same as saying 4 to the exponent 0. So we're going to plug that in. So I have 4, 3x minus 2 is equal to 4 to the 0 power. Now that we have the same base, we set the exponents equal to each other. So 3x minus 2 equals 0, and solve for x. So I have 3x equals 2. Divide by 3, x is equal to 2/3. Number 6, do we have the same base?
Yes.
So we just set them equal to each other, the exponents. So we have 2p is equal to negative 2p minus 1. I'm going to add the 2p over. So I have 4p equals negative 1. Divide by 4, and I have p is equal to negative 1/4. Go ahead and try number 7. We have the same base already on number 7. So you're just solving for a. Okay, so you should have got negative 2a is equal to 2 minus 3a. Add the 3a over. Negative 2a plus 3a is just a. And then you're left with 2 on the other side, so you should have got a is equal to 2. And then same with number 8. Do we have the same basis? Good, so we're just going to set the exponents equal to each other. So 2x plus 2 is equal to 3x. Solving for x, I'm going to subtract the 2x over, and I'm left with 2 equals x. And again, you could do it in any direction, you'll get the same answer. So 1 through 8 were the easier ones because we always had a base with an exponent equal to another base with an exponent. Now looking at number 9, we have that third element added to our equation. So refreshing the properties of exponents, if we have the same bases, so a to the x being multiplied times a to the y, that's the same as saying a to the x plus y. So that's the one I wrote above. I'm just rewriting it here. Also, we have the property of division. So the first one is multiplication, the second one is division. So if we have a to the x divided by a to the y, we're going to have a to the x minus y. So again, these are all the same bases. We still have to use that concept of same bases in order to continue our equation. Okay. So for example, in number 9, do all 3 terms have the same base?
Yes.
Yep, they all have the same base, so that means we can continue. Our goal, however, is to have one term equal to another term. And right now we have two terms equal to another term. So we're going to use these properties to simplify this part of the equation. Okay? Because in this part, the bases are being multiplied, so that means we're going to do what to the exponents? Add them. Okay? So we have 6 to the power of 3m plus negative m. I'm just writing out each step. We're adding these exponents. Okay? I can simplify that by saying this is the same as 6 to what power? 2m, because 3m minus m is 2m. Okay? And then I bring down the other side of my equation, and I have 6 to the negative 2m. Okay? Now, once I get here, this is like what we were doing in problems 1 through 8. Okay? We have a term equal to another term. If the bases are the same, then we just set the exponents equal to each other. So since we already said that our bases are the same, we're going to have 2m equal to negative 2m. Good, which is going to be 0. So I'm just going to show each step. So I'm going to add that 2m over. I have 4m equals 0. Divide by 4. M is equal to 0. So the only difference here is if we see the multiplication or division, we have that one extra step. Okay? And we're going to always follow either that first property or that second property. Okay. So looking at number 10, what do we notice about the left side? It's division. So what are we going to do to the exponents? Subtract them. And again, double check that, okay, all our bases are the same. They're all that 2. So since we're dividing here, we're going to subtract the exponents. So this 2x divided by 2x is going to be 2 to the power of x minus x. And then I'm going to bring down my other side, 2 to the negative 2x. On the left side, x minus x in the exponents is going to give us what number? Looking right here. This is going to give us 0, and then anything to the 0 power is 1. So this is, well, okay, it is 1, but remember we want our bases to be the same, so I'm going to write this as 2 to the 0 power. That way I can write my exponents equal to each other. But yes, off to the side, this would be 1. Okay. Now that I have my one term equal to another term, and they have the same base, I'm going to do 0 is equal to negative 2x. Oops. Divide by negative 2, and I get x is equal to 0. Any questions so far? Okay, let's look at number 11. So on number 11, looking at the left side, what are we going to have to do first?
Add them together.
Add them together because we all have the same base of 10. So we're going to add these ones together. So this is now 10 to the power of negative 3x plus x is equal to, we're able to write that fraction 1 over 10 as 10 to a power. So 1 over 10 is equal to 10 to what exponent?
Negative 1.
Negative 1. Perfect. So 1 over 10 is equal to 10 to the negative 1 power. So what that -1 exponent does is it moves our base into the denominator. So if we had 1 over 5, that's the same as 5 to the -1. So whatever number is on the denominator is going to become our base. And then if there is just a 1 on the top, then it's going to be to the -1 power. And I wanted that in red, so I'm going to box that in red. Okay, so this is 10 to the -1 power. So now that we have the same bases, and we have one term equal to another term, what are we going to do next? Correct, so -3x plus x is equal to -1. -3 plus x is -2x, so that's equal to -1. Divide by -2, we get x is equal to 1/2.
So if it was like 2 out of 10, would it be negative 2 exponent? Like scaling it wise? Because like if it's 1.
Not necessarily, because if it was like, so if it was 2 out of 10, that can reduce to 1 over 5. So that would be 5 to the -1. If it wasn't one that could be reduced, like 3 over 10, well, that's the same as saying 1 over 10 plus 1 over 10 plus 1 over 10. So that would be 10 to the -1 plus that many. You won't see these, though. They'll be able to reduce. When we get to something like this just becomes a little bit more complicated. But yeah, every time your fraction will be able to reduce. Okay. So looking at number 12, first, do we have the same base on every term?
Yes.
So we have the same base of 3. What are we going to do to the left side to make it 1? To combine it.
Add them.
Good, we're going to add them because the terms are being multiplied. So we have 3 to the power of -2x plus 1 plus, so -2x minus 3. I don't have to write plus a negative, just leave it as a negative. Is equal to 3 to the -x. Okay. Now that I have a term equal to another term with the same base, what am I doing to the exponents?
Combine like terms.
Good, I'm going to combine like terms, but first I'm just going to write this out as an equation without the bases.
Oh, true.
So I had -2x plus 1 minus 2x minus 3 equals -x. So yes, I'm going to combine like terms. So I have -2x and -2x, which is -4x, and 1 minus 3, which is -2, is equal to -x. Okay. I'm going to add the 4x over, and I get -2 is equal to 3x. Divide by 3, I get x is equal to -2/3.
What's all going to be on the next test?
Topics 15 to 27. So nothing before 15. That was all on the midterm. Okay, so looking at number 13. Do we have same bases?
No.
No. So we have these as the same bases, but not that 64. So off this side, we say 64 is the same as saying 4 to what power?
3.
3. So 64 is the same as saying 4 to the third power. So I'm going to rewrite this equation, but instead of 64, I'm writing 4 to the third power. Now that I have all my bases the same, how am I going to simplify my left side? Add them. Good. So I have 4 to the power of negative 2x plus x is equal 4 to the third power. What's my next step?
Bring them down.
Good. Bring the exponents down. So negative 2x plus x is equal to 3. Negative 2x plus x is negative x equals 3. Divide by negative 1, we get x is equal to negative 3. Okay. So again, this part is the only new part. Okay. Once we get our same bases equal to each other, this is just what we learned in the beginning of the semester, how to solve for one variable. Okay. So on number 14, do we have same bases? No, so we have the first two are the same. So that means that last one also needs to be 6 to the power of something. So since this is a fraction of 1 over 216, we know our exponent is going to be what? Positive or negative? Negative. So since we have this fraction, our exponent will be negative. Okay, just like when we had 1 over 10, that became 10 to the negative 1 power. Okay, so for 216, we need to find what exponent, 6 to what exponent gives us 216? So we're just looking at this part. What would give us 216? So you would check on your calculator. 6 to the first, 6 to the second, 6 to the third, until you got one that matches. 3? Yep. So this 216 is equal to 6 to the third power. But we want this as 1 over 216, so this is going to be 6 to what power? Negative 3. So now that we found the correct base with the exponent to plug in, we're going to rewrite our problem as 6 to the negative 2x times 6 to the negative x is equal to 6 to the negative 3. So now we have the same base of 6 on every single term. What's our next step?
Bring them down.
Not yet. That's
put them together, the two sides on the left side.
good. On the left side, since we're multiplying, we're going to add the exponents. So 6 to the power of negative 2x plus a negative x, so I'm just going to write minus x, is equal to 6 to the negative 3. Now that we have one term equal to another, now we bring down our exponents. So negative 2x minus x is equal to negative 3. Negative 2x minus x is negative 3x equal to negative 3. Divide by negative 3, and I get x is equal to 1. Number 15. Notice in number 15, not only do we need to change one of our bases, we're going to have to change 2 because we only have this 2 to the x here, meaning this term and this term both have to have 2 as their base. Okay. So starting off with 1 over 32, we know that 1 over 32 is going to have a new exponent that is what? Positive or negative? Negative. So we're going to do 32 is the same as saying 2 to what power? Good, negative 5, because it would turn it into that fraction. So 32 is the same as saying 2 to the 5th power, but we want 1 over 32, so that's 2 to the negative 5th power. Notice when we solve this out to the side, we also got our third term. So our third term of 32 is just 2 to the positive 5 power. So this one and this one. So rewriting this, I have 2 to the x times 2 to the negative 5 power is equal to 2 to the positive 5 power. Okay. Now I have all the same base of 2. So what's my next step? Add them together, because remember the left side, since I have that multiplication, I'm going to have to add those exponents. So this is 2 to the power of x minus 5 is equal to 2 to the 5th power. Now what's my next step?
Bring them down.
Bring them down. X minus 5 is equal to 5. Add 5 over, and I get x is equal to 10. And that's my answer. Okay. Any questions so far? Go ahead and try 16. So 16 already has all the same bases. Okay, so your first step should have been looking at the left side, and since the left side is multiplying, we're going to add the exponents. So this is 2 to the power of negative 3p plus 2p is equal to 2 to the power of 2p. Now that we have a term equal to another term, we're going to bring down our exponents. So negative 3p plus 2p is equal to 2p. I'm going to combine like terms. Negative 3p plus 2p is just negative p is equal to 2p. I'm going to add the p over, and I get 0 is equal to 3p. Divide by 3, and I get p is equal to 0. Okay, so what was it? 9 through 16 was the next level up from the first 8. Now, the hardest you're going to see is problems like 17. Okay. Notice on 17, we have 64 as a base, we have 16 as a base, and then a 16 as the third base. So before doing anything, what would be your first thought to try as the base? 16, that would be my first thought too. So let's go off to the side and see if we could get 64 equal to 16 to what power?
Is it 3? It is 3, right?
It's not 3, nope. So check on your calculator, do 16 squared. And right away you should see that 16 squared is nowhere close to 64, okay? So that tells us that we can't use 16 as a base. So we're gonna have to change all 3 bases for them to be similar. So looking at these numbers, 64 and 16, what could be a smaller number that we could use that would work for all 3? It's not 3. Think of like the multiples of 64 and 16. It would be 4. Because if we took, so we said this doesn't work. So that means we're going to have to change them all to base 4. So 64 is equal to 4 to what power?
To the 4th?
Also the 5th. No, wait, no, no.
Mm-mm. 4 to what power is 64? To the third. So 64 is equal to 4 to the third. Okay, that's one thing solved. Now let's do 16. 16 is equal to 4 to what power? Squared. So this is 16 is equal to 4 squared. Okay. Now that we have those two, we're going to plug them back into our equation. So 64 we said is the same as 4 to the third power. 16 we said is 4 squared. So times 4 squared, but we still have that negative 3x up there. So I'm going to write it in parentheses next to it. Equals, again we said 16 is 4 squared. And then since I already had exponents there, I'm going to write that 3x minus 2 in parentheses. So now I'm able to continue and solve because I have all my bases of 4. Okay, so this would be the only additional step. If you can't find a base that works, you're going to have to find a smaller number that could work for all 3.
Which is the GCF, isn't it? Or the...
Yeah, you could think of it like the GCF. Usually they are a smaller number, so it's usually like numbers smaller than 10.
Okay.
Usually, not all the time, but usually, yes. Okay. Okay, so for the left side, what are we going to do to simplify? Add them. So I have 4 to the third power plus 2 times negative 3x all in one exponent. So we're adding them together. And then I'm bringing down my other term. And what's my next step?
Bring them down.
Good, bring down my exponent. So I have 3 plus 2 times negative 3x is equal to 2 times 3x minus 2. What am I going to have to do to the 2's on both sides? Distribute. So I'm going to distribute the 2 here and the 2 here. So I have 3 minus 6x is equal to 6x minus 4. I distributed those 2's on either side. Okay. Now I'm going to get my x's and my numbers. two separate sides, so I'm going to subtract my 6x over. And I have 3 minus 12x equals negative 4. Subtract 3. I have negative 12x equals negative 7. Divide by negative 12, and I get x is equal to 7/12. Remember, you could have done it the other way. You could have added the 6x over in the beginning and then added the 4 over to the other side. You'll get the same answer. Okay, so these are the most difficult problems you'll see where you have to change every single base. Okay. Number 18. Again, notice on 18, we do not have similar bases. We have an 81, a 243, and a 3. Okay. Our first thought is always to try that smaller number as the base. So what are we going to try first?
81 is equal to 3 question mark exponent.
Correct. So we want to try to get all the same bases of 3. So for 81, we say 81 is the same as saying 3 to what power? So this is where you go on your calculator and you do 3 squared, 3 to the third, 3 to the fourth. Good, and you should get 3 to the fourth. And then we check 243. So 243 is the same as saying 3 to what power? I believe we did this one a couple questions up. Yeah, 5. Okay, so in this case it worked. We could use 3 as our base. Okay, so we only had to change 2 this time. So instead of 81, I'm going to put 3 to the 4th power. So 3 to the 4th power, but I still have an exponent of 3n plus 2. So I'm just going to write that in parentheses next to it. And then on the bottom, we know 243 is 3 to the 5th power, but I still have an exponent of negative n. So I'm going to write that in parentheses next to the 5. And then bring down my 3 to the 4th. Okay. Now I have everything in base 3. So how can I simplify my left side?
Subtract them.
Good, subtract. Because remember, if you see division, that means subtract. So I have 3 to the 4 times 3n plus 2 minus 5 times negative n. Yeah. Okay. And then bring down that 3 to the 4th. Okay. So now that I simplified the left side, what's my next step?
Bring them down.
Bring everything down. So 4 times 3n plus 2 minus 5 times negative n is equal to 4. What am I going to do first on the left side? Distribute. So I'm going to distribute this 4, and I'm going to distribute this negative 5. So I have 12n plus 8 plus 5n equals 4. That's what I get after I distribute the 4 and after I distribute that negative 5. Now I just combine like terms and solve for n. So 12n plus 5n is 17n plus 8 equals 4. Subtract 8 to the other side. I get 17n equals negative 4. Divide by 17. I get n is equal to negative 4/17. go ahead and try 19. On 19, remember your first thought should be to try to get them all in base 9. But if base 9 doesn't work, you're going to have to find a smaller base. Okay, so looking at 19, remember your first thought should be, okay, I'm going to try 9 first. So if you try 9 first, let's say we're going to turn 81 in terms of 9. So we know that 81 is equal to 9 squared. Now we would have to try 27. 27 is equal to 9 to a certain power. Since squared already gave us 81, no other exponent that you write is going to give us a number smaller than 81 for that 27. So this tells you that this doesn't work. And we would have to try a smaller number for all 3. Correct, 3. So you would do 81 is equal to 3 to what power? Which we know is 3 to the 4th power. And then 9 is equal to 3 to the what power? 2nd power. And then 27 is equal to 3 to the what power? 3. Okay. Here, we were able to use 3 as all of our bases. So plugging that in, I have 81 was 3 to the 4th. Times 9, which was 3 squared, but they already had an exponent, so I'm going to write that in parentheses, is equal to 27, which was 3 cubed. Okay. Then you should have done the left side by doing what to the exponents? Adding or subtracting? Adding. So this is 3 to the power of 4 plus 2 times negative 2b minus 2. Is equal to 3 to the 3rd. Now that we have the same bases equal to each other, what are we doing to the exponents? Bring them down. So 4 plus 2 times negative 2b minus 2 equals 3. What are we going to do to the 2 on the left side? Distribute. So we have 4 minus 4b minus 4 equals 3. Okay. Simplifying the left side, we have 4 minus 4, so that's cancels. And negative 4b equals 3. Divided by negative 4, we have b is equal to negative 3/4. Okay, so remember to always try what you're thinking first, because sometimes it might work. If it doesn't work, then you find a smaller base. Okay, last one, number 20. Okay, on number 20, our first guess would be to try what base? Yeah, we would assume, okay, maybe we'll try 9 because there's already 2 9s there. But we just said in the last problem, we could not find an exponent for 9 that would give us 27. So since we can't find that, and I'm going to write that off to the side, so 27 is equal to 9 to what power? This doesn't work. So then we would try the base 3. So we know that 9 is equal to 3 to what power? 3 squared, right? 3 squared is 9. And 27 is equal to 3 to what power? 3. So using that information, we're going to plug that into our equation. So instead of 9, we're writing 3 squared, bringing down that negative 3x in parentheses because it was already there. Times 9 is 3 squared, bring down that x, is equal to 27, which we said was 3 cubed. Now we have all the same bases of 3. So what are we going to do to the left side? Add them together. So we have 3 to the power of 2 times negative 3x plus 2 times x is equal to 3 to the 3rd power. What's our next step? Bring them all down. So 2 times negative 3x plus 2 times x is equal to 3, equal to 3. Okay. Now I'm going to distribute these 2's and combine like terms. So 2 times negative 3x is negative 6x. 2 times x is just 2x. Negative 6x plus 2x is negative 4x equals 3. Divide by negative 4. We get x is equal to negative 3/4.